Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Muhyiddin Abdul Rahim. So I'm from Group 9. This group consists of four members. Number one is me, Abdul Muhyiddin. Second is Muhammad Abid. Third is Muhammad Koim. And lastly, Muhammad Uthman. So for our project, which is the process scheduling in operating system for operating system subject. So let's move on to the first slide, which is the introduction. So the objective for this project is to examine and evaluate various process scheduling algorithms employed in operating system. So the scheduling algorithm that is mentioned will be the first come first serve, round robin, shortest job first, and scheduling. So these four will be our main case to be studied. So the objective of this project is to execute scheduling algorithms, simulate their performance, and conduct a comparative analysis based on metrics such as turnaround time, waiting time, and other relevant factors. Okay, next stop is the problem statement. So insufficient process scheduling can cause resource contention, reduce responsiveness, and underutilization. So multi-user environment, CPU-bound task, real-time system, input-output bound processes, servers environment, distributed computing, power constrained devices, and real-time multimedia applications are included. This study uses scheduling algorithm to address the issue. So let's move on to the objectives. There will be four objectives as a total for this project. Number one is the familiarity with the process scheduling as well as the terminology used in operating system. Next is to investigate and get familiar with the variety of scheduling algorithms such as the number one FCFS, first come first serve, round robin, shortest job first, and lastly priority scheduling. So number three, the objective is utilizing simulation, evaluate and using simulation to evaluate each algorithm's performance relative to the others. And the last objective, which is number four, discuss how just and efficient each algorithm is in terms of ranking the processes to be completed first. Alright, what is our project for today? What we've been doing, which is number one, to research and learn about the operating system, task scheduling first. Next, to examine scheduling algorithm like first come first serve, round robin, shortest job first, and priority scheduling. So after that, each of us will write C and C++ programming codes to implement the scheduling algorithm. So for each of the scheduling algorithm, you can see that each of it will have different codings. So simulations will be run to compare each algorithm performance in terms of process completion time, wait time, average process completion time, and average wait time. Discussing each scheduling algorithm pros and cons, we also assess each algorithm's fairness and prioritization. Alright, so this is my part for the scheduling first come first serve SCFS. So what is FCFS? The FCFS algorithm is a straightforward CPU scheduling method. Under FCFS, processes are executed in the order in which they enter the ready queue. So if in the process, it's like process 1, process 2, process 3, it goes in that order. It doesn't care how long it is, but then if it's first, it will serve the first one that is already in the waiting order. So the first arrival processes is executed first, and subsequent processes are executed in the order of their arrival. FCFS is a non-preemptive algorithm, which means that once a process begins executing, it will continue until it completes or blocks for I/O operations. Then only does the subsequent process in the queue begin execution. So if the first process is already like 2 minutes, but then the second process is like a few seconds, but it will complete the first one because it is first come first serve basis. Alright, so this is the programming code. We enter in the CPU simulator and then we able to initiate what is FCFS. And based on the simulator, this is the result and analysis that we get. So for the process ID number one, the first time is 4, the waiting time is 0, and turnaround time is 4. So there's no waiting time because the process ID number one is the first one to be executed. So process ID 2, burst time 2, waiting time 4, turnaround 6. And then process ID number 3, burst time 3, waiting time 6, turnaround time 9, and then process ID number 4, burst time is 1, waiting time is 9, and the turnaround time is 10. So the average waiting time is 4.75 minutes, and then average turnaround time is 7.25 minutes. That is for the FCFS. So that is all from me. Thank you.
Hi, Assalamualaikum and good morning. My name is Muhammad Qayyim bin Isa and my metric number is AN200010. Now I will present about shortest job first, which is SJF. For the algorithm description, SJF is a CPU scheduling algorithm used in operating system. It prioritizes processes based on the length of their next CPU burst. Also, the algorithm schedules the process with the shortest remaining time. SJF can be implemented as non-primitive or primitive, which is SRTF. Primitive SJF allows for preemption if a shorter burst process arrives. Meanwhile, non-primitive SJF allows a process to continue until completing its burst. SJF is optimal and minimizes the average waiting time. And finally, burst time need to be accurately known or estimated for optimal performance. For the program code, this is what that we put in the C++ compiler. Next, about simulation result and analysis. So from the simulation that we put the code, first we enter the number of process, which is 4. Next, enter the burst time for each process, and it will show the waiting time and turnaround time. It also show the average waiting time and average turnaround time. Next, for the comparison with the theoretical analysis. So from the theoretical analysis, from the Gantt chart, it showed that P1 is the smallest and P4 is the biggest. For waiting time, we also calculate it from the P1 to P4. P1 we got 0 ms, P2 we got 2 ms, P3 5 ms, and P4 9 ms. From the theoretical also, we count the average waiting time and turnaround time, and finally the average turnaround time. So based on simulation and theoretical, the average waiting time is 4 ms, also same with the theoretical, and average turnaround is 7.5 ms, also same with the theoretical result. So that's all from me. Thank you.
So next is the round robin part, and first we go to the algorithm description. So round robin is a CPU scheduling technique that requires several processes to provide equal execution time. Processes are placed in a queue in this method, and the CPU gives each process a defined time slice to run before moving on the next process. If a process finishes inside its time slice, it gets removed from the queue. If it does not complete within the time slice, it is temporarily stopped, and the next process in the queue is given the opportunity to execute. This step is repeated until all processes have completed their execution. The round robin strategy guarantees that no process has long-term control on the CPU, encourage fairness and allowing each process to advance. Next is the program code for the round robin, and the output of this coding will display the enter details of process, arrival time, burst time, and the time quantum. Then we go to the next part, which is simulation result and analysis. By executing process in a periodic loop with a set time duration, the round robin algorithm ensures that each process receives an appropriate amount of CPU time. The approach prevents process starvation by allowing all processes to execute within the set time quantum. The procedure's turnaround and waiting period vary depending on their burst and arrival timings. P3 and P4 have the shortest burst time and the shortest waiting period. P1 and P2 have the largest burst time and the longest waiting period. Next, we go to the comparison with theoretical analysis. So the theoretical analysis is precisely matched by the simulation results produced using the round robin scheduling method. the simulations, average waiting time and average turnaround time are identical to the theoretical figures. This consistency indicates that the simulation accurately represent the round-robin algorithm's behavior. It confirms that simulation validity and the computation's accuracy.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Uthman bin Azlan. I will present about priority scheduling. So first is algorithm description. Priority scheduling is a CPU scheduling method that prioritizes tasks depending on the priority levels assigned to them. The task with the highest priority is complete first, ensuring that critical or time-sensitive tasks are complete as soon as possible. The low priority jobs, on the other hand, can be repeatedly delayed if not appropriately implemented, potentially leading to hunger. It is critical to build the algorithm in such a way that this is avoided and lower priority jobs can eventually be done. Next, this is program code that I use to simulate the priority scheduling. So this is simulation result and analysis. From the left side is simulation result and from the right side is table of simulation result. Based on the table, the average waiting time is 3.5 millisecond while the average turnaround time is 6 millisecond. As a result, the turnaround time for priority scheduling is typically 6 millisecond and the waiting time is typically 3.5 millisecond. It's vital to remember that the performance of priority scheduling can change depending on the process burst, duration, and priority assignment. Next is comparison with theoretical analysis. For simulation result, average waiting time is 3.5 millisecond and average turnaround time 6 millisecond. For theoretical result, average waiting time is 3.5 millisecond and average turnaround time is 6 millisecond. In terms of both the average turnaround time and the average waiting time, the simulation result correspond with the theory result. According to the simulation, which is correspond with the calculation made in theory, the average turnaround time is 6 millisecond and the average waiting time is 3.5 millisecond. Lastly is conclusion. In conclusion, the study research and compare various CPU scheduling methods such as first come first serve, shortest job first, priority scheduling, and round robin. These algorithms are critical in establishing the order in which processes are assigned to the CPU, which affects system performance, fairness, and responsiveness. Overall, the project has shown the need of selecting a suitable scheduling algorithm based on the requirement and characteristic of the system. Operating system can achieve efficient CPU use, reduce waiting times, and fair process execution by properly implementing this algorithm. Okay, that's all from us. Thank you.